Alrighty, folks. Let's go ahead and go through our electricity and magnetism Kahoot, and I'm going through as, hey, amiable pony. How perfect is that? Alrighty, let's get started here. So, with our first question, electricity in a closed path is called well, if you have the closed path and you have electricity flowing through it, that is going to be a circuit. All right, next up, the flow of electricity in a circuit. So the actual flow itself is the current. So when electrons are moving through conductible or material that is conductive, or that is a conductor, sorry, that is going to be current. All right, next up. Allows electricity to flow, kind of just gave this one away, but that's going to be a conductor. So, conductor allows electricity to flow through it. Metallic objects are conductors. All right, next up. The plastic around the wire. So when you touch a wire, if you touch this plastic part, you will not get shocked because it is an insulator. All right. If the lights are off, the circuit is, so if a light is turned off, that means that there is no electricity flowing, meaning that circuit is open. All righty. A battery has two charged ends, which are one of each, positive and negative. You need electricity to flow from one end to the other, so you have to have positive and negative terminals. All right, next up. In a parallel circuit, the current, so this is the flow of electrons, and this is an example of a parallel circuit, and you can see that the electrons have multiple paths that they can travel. And so that means it splits and goes through more than one path. In a parallel circuit, if one bulb goes out, well, as we just said, the electricity, the electrons travel in more than one path. So if one light bulb goes out and that opens the circuit there, the electricity can still travel through the rest of, or the other paths, and so that means the rest of the light bulbs will stay lit. In a series circuit, if a light bulb goes out. So let's take a look at our circuit here. This is a series circuit, and you can see there is only a single path for our electricity to flow. So if one of these light bulbs go out, the electricity can no longer flow through it, and therefore the electricity stops flowing, the electrons stop flowing, and they all go out. A circuit has a voltage of 9 volts and a resistance of 3 ohms. What is the current? All right, so we are using Ohm's law here. Here's our formula triangle, and we are given voltage and we are given resistance. So V and R, that means we're solving for I, which is current, so cover that up. Voltage divided by resistance, 9 divided by 3 is 3 amps. What unit is used to measure resistance? So remember that resistance is going to be measured in ohms. Next up. The N and S on this bar magnet represent, so we're looking right here at the N and the S, and in a bar magnet that is going to be at the ends of the bar magnet where the magnet is strongest and therefore the magnetic poles. What does it mean that there is no iron filings in the middle of these two magnets? So, got a magnet, no iron filings there, and therefore there is no magnetism there, and that means that the area between the magnets has a very weak magnetic field. If the magnetic field had a lot of lines, that would be very strong. If opposite poles were facing each other, the magnets would have a strong magnetic field between the two of them, and there would be a lot of iron filings. And if the magnet was broken in half, these would also be opposite poles. So this means that these are same poles, and therefore there is a weak magnetic field. If you break a magnet in half, well, as we just said, if you break a magnet in half, you are actually going to have a magnet with a north and south pole, because remember, the magnetic domains are aligned, and so they're all pointing in the same direction. So if you break this in half, you just have the same magnetic domains pointing in the same direction, and at the bottom you have a south pole and a north pole, and at the top here you have a north pole and your south pole remains. A compass is a small magnetic needle. What causes it to work? So we got our compass, small magnetic needle. That means we need another magnet. Well, sun's not a magnet. The orbit of the moon is not magnetic. The rotation of the Earth's axis is not magnetic. The Earth's magnetic field, though, is magnetic. So a compass's needle aligns with the Earth's magnetic field. A compass needle moved when near a wire with a current running through it. This tells us what? So if the compass needle moves, that means that the compass needle the magnet is being affected by something, and so magnetism is going to be affected by other magnetic fields, and therefore an electric current creates a magnetic field. Which of the following is magnetic? So we have magnetic domains here, and remember that in order for a magnet or a ferromagnetic material to be magnetic, all of its magnetic domains, or at least most of them, need to be aligned, and therefore B is going to be the magnetic material. Well, that's supposed to be correct. So yeah, ignore that. The answer will be B when you take the Kahoot, and welcome to mistakes happening in the moment. Fun. All right. A ferromagnetic material is not. So a needle is an example of a ferromagnetic material because it is made of iron. And so we are saying it is things that is not. Well, it is metallic, and it is able to be turned into a magnet because it's ferromagnetic, and it is filled with magnetic domains. However, it is not always a magnet. It has to be magnetized first. All right, last question. If you add a commutator to an AC generator, alternating current, it becomes a. So this is an AC generator with a commutator added, and so that is going to then allow the current to continually flow in a single direction, meaning it becomes a DC generator. So there you go. Hopefully that is helpful, folks. Mistakes happen, and I'll make sure that that is fixed so that you got the right answer if you chose the correct answer on that question about magnetic domains. But otherwise, if you have any questions, please feel free to reach out to your teacher. Have a great day.